Alright, this video is for lesson 8.4. We're talking about the law of cosines today. And last time we talked about the law of sines. So this law is quite a bit different from the law of sines. This is what the law of cosines looks like. And the law of cosines is a relationship between three of the sides of the triangle and one of the angles. And it's written three different ways here, but it really just depends on which angle you're focused on, and they're essentially really all the same, just looking at the triangle from different perspectives. So here is triangle ABC, and we have angle B is 38 degrees. We have side A is 12 and side A or C is 16, and we want to solve and find the length of side B. So in this case, we're going to use the law of cosines. It looks like this. B squared equals A squared plus C squared minus 2AC cosine B. And if you're following along in your notes, that should be at the top of your paper. So what we're going to do is just put in the quantities that we know and manipulate the equation to find side B, which we don't know. So we'll leave this B squared here because we're not sure what B is, but we know what A is. A is 12. So we square 12. We know what C is. It's 16. And the formula has a 2 here. We put in side A is 12. Side C is 16. And that's all multiplied by the cosine of angle B, which is 38 degrees. So we're trying to get B by itself. We're trying to solve for B here. And on this right-hand side of the equation right now, we just have really a whole bunch of numbers, and we can calculate that. And your calculator will do that really well. And you don't have to be particularly careful about this. Just type it in the way it is. 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of angle B. And, just make sure you're in degree mode if you're not getting the same answer as I'm getting. And we find that B squared is equal to 97.4. Again, I just calculated that whole right-hand side of the equation. And as your final step, as you're solving, you just need to remember that this is B squared, so we need to take the square root of both sides. And when we do that, we find that angle B is equal to 9.9. I'm going to just round to the nearest tenth. So that's essentially how to use the law of cosines to find the length of an unknown side. And it's very pretty straightforward. And once you've practiced that a few times, it's not very difficult. Finding an angle always, no matter which type of problem you're doing, whether you're doing right triangle trig, whether you're using law of sines, whether you're using the law of cosines, finding an angle is always a little bit trickier. So here's a situation in which we're trying to find angle C. So if we draw a picture of our triangle, and I'm not going to worry too much about having it be perfectly to scale, but if this is side A and it's 7, and this is side B and it's 9.4, and this is side C and it's 13 units long, what we'd like to find in this triangle is we'd like to find angle C. And remembering our conventions, this is angle C up here that's across from side C. So we're trying to find this angle. Well, if you look at the law of cosines, there's only one of those versions that has angle C, and it's this one. C squared equals A squared plus B squared minus 2AB cosine C. So if we put in the things that we know this time, we know that little c, side C is 13, and we know that A is 7, and we know that B is 9.4, and we know that A is 7 on our triangle, and side B is 9.4, and cosine angle C is here at the end. Now, as we're solving this one, it's a little bit less straightforward. So really important to realize that these items over here, all of these things are actually one term. They are right now linked together. It's a cosine of c and it has a coefficient. So I'm going to calculate that coefficient for c really quick. It's 2 times 7 times 9.4, and that's 131.6 cosine c. That has to stay together. It's being subtracted. And I'm going to figure out these other quantities now as well. 13 squared is 169. 7 squared is 49. And 9.4 squared is 88.36. So we're trying to get angle C by itself. We're trying to solve for C. So it's fine right now to go ahead and subtract this and subtract the 88.36. But you can't break apart this coefficient from its cosine. You've got to leave that together for just a minute. So these we are going to move to the other side. So on the left-hand side now, we have 169 subtract 49 subtract 88.36, and we have 31.64. Again, these are not there anymore. We have negative 131.6 cosine c. Don't lose the negative. That is part of it as well. So now we've got this 131.6 negative times cosine c. We can divide that out because it's times by the cosine. So we'll divide. This reduces. And we have the equation. Let me divide that really quick. Negative 0.24043 is equal to the cosine of angle C. Anytime you're trying to find an angle like C, with the trig function, you're gonna use the inverse to undo that cosine. So in my calculator, I'm typing in the inverse cosine of negative 0.24043. And that's equal to angle C, and my calculator tells me angle C is 103.9 degrees. So it does take a little more care when you're finding a missing angle in your triangle with a lot of cosines. Just if you can remember to keep the cosine's coefficient with it for a minute, you'll be fine. But that is a little bit trickier than finding a missing side. So we're going to go through two triangles now, solving the triangles. This triangle right here has two sides given to us. One is 23 and one is length 20, and we have the angle in between them is length 47. Now last time we talked about the law of sines, and I couldn't begin this problem by using the law of sines because you might have noticed last time we talked about a little bit, with the law of sines you always have some sort of partnership, a set of partners that can help you use the law of sines. In this case, I know this side is 20, but I don't know this angle, so that one doesn't work to help us with the law of sines. I have this angle, but I don't know this side, so I can't use that to help me use the law of sines. And while I know this side, I don't know this angle. So there is no partnership that I can use to help me use the law of sines, and that tells me that I have to approach this problem from the perspective of the law of cosines. So I'm going to label this angle that I know angle A and mark this side A. And this is side B, and this will be angle B, and this is side C, and this will be angle C. And you could have picked different letters, that's just what I chose. So I know I'm going to use the law of cosines because I don't have a partner to help me. And I have angle A, so I am going to find, to begin with, the length of side A. So I'll use the law of cosines. A squared equals b squared plus c squared minus 2bc cosine A. And on your test, you will have a formula sheet. I'm not going to test your memory. I'm going to test if you know how to use the formula. And if I fill in the quantities that I don't know A, that's what I'm trying to find. B is 23. C is 20. And we'll put that 23 in and that 20 in for B and C again. And it's the cosine of angle A, which in my triangle is 47 degrees. So on the right-hand side, we're back to finding a side here. The right-hand side is just a number, and our calculator can calculate that number for us. Let me put that in. 23 squared plus 20 squared minus 2 times 23 times 20, cosine 47. And we get 301.56. And again, I just used my calculator to calculate that. And I take the square root of that number, because I don't want A squared, I want A. And I find that side A is equal to 17.4 meters in this case. So I've found the unknown side in the triangle, and I still need to find the unknown angle B and the unknown angle C in order to solve the triangle. Now at this point, if you were a big fan of the law of cosines, you could continue using the law of cosines and find an angle, but a lot of times people would just prefer at this point to switch to the law of sines because it's a little bit easier to find angles using the law of sines once you're familiar with both of them. But you could again use the law of cosines if you wanted, but at this point, since we have found the length of side A, we now have this partnership of A's that can help us find the other two angles in the triangle. I'm going to start by finding angle B, and I'm going to use the law of cosines. I'm sorry, oh my gosh. I'm going to find angle B, and I'm going to use the law of sines. Again, because I have that partnership with the A's. So the equation that I'm going to use is that the sine of angle B over B, because I'm trying to find B, and I'm going to set that equal to the sine of angle A over A. Again, I chose the A's because that's the ones I know. So if I plug in the values that I don't know B, but I do know that side B has a length of 23. I know angle A is 47, and I know side A, I just calculated it to be 17.4. So I'm going to solve this equation for angle B, and I'm going to multiply both sides of my equation by 23. So I get the equation, the sine of B is equal to, and my calculator can calculate this for me, 23 sine 47 divided by 17.4. And I'll write it here in my equation on the next line. 23 sine 47 divided by 17.4. And I get 0.96673. So if I take the inverse sign of that decimal value there with that second button, it will give me angle B, which happens to be 75.2 degrees. So I'm going to add that to my triangle. Oops, sorry. 75.2. And now, we've gone to a lot of work to find that side A, and then we went to all this work with the huge equation to find the angle B. Angle C, it turns out, is fairly simple to find. We know that the angles add to 180. So if we just take 180 and we subtract that 75.2 and subtract the 47, we find that angle C is 57.8 degrees. And we're done. We've solved the entire triangle. So we started in that case with two sides and the angle in between them. We start with law of cosines to find the missing side, and then we use the law of sines to find one of the angles, and we knew the other one would just be whatever we needed to add up to 180. This one we're going to solve as well, but it's a little bit different. We're going to start this triangle with 3 of the sides known, and our job is to find the measure of each angle. And it was a good idea, good rule of thumb when you're using the law of cosines to just find the angle opposite the longest side first. Essentially, you're finding the largest angle first. And we mostly just do that to avoid having an ambiguous sign in a minute. So we're going to start by finding, let's call it angle A. So I'm going to use the law of cosines here because while I know all of the sides, I don't know any of the angles. So I can't have any partnerships because there are no angles at all right now. So we're going to find angle A to start with. So we'll use the law of cosines. A squared equals B squared plus C squared minus 2BC cosine A. And let's see, we'll put the B up here at the top and the C down here. You could have flip-flopped that if you wanted, and I'll put in the values that I know. 9.1 squared equals 8.3 squared plus C is 4.9 squared minus 2. And I put in the B value, and I put in the C value, and cosine angle A. That angle A is what I do not know. 9.1 is 82. I really don't want red. Oh, sorry. 82.1. Sorry, 81. 8.3 squared is 68.89. And we want to add 4.9 squared. That's 24.01. And remember to keep this coefficient with your cosine. So 2 times 8.3 times 4.9 is a coefficient of 81.34 with the cosine A. And remember, that's sticking together like glue. Don't break it apart yet. So we can move these numbers over by subtracting them from both sides. So that's gone. And subtract 24.01. So we get 82.81. Subtract 68.89, subtract 24.01, and we get negative 10.09 is equal to negative 81.34 cosine A. Now that we've got that cosine there by itself, sort of we can divide by 81.34 negative, which will give us that the cosine of A is equal to 0.12405. So when we do our inverse cosine, that leads us to the solution that angle A is equal to 82.9 degrees. So I'm going to put that in my triangle. 82.9 degrees. And now that I've found angle A, and again, my goal is still to find all of the angles, but now that I've found angle A, I have this partnership here with the A's that I can use to help me find angle B. Whoa, sorry. Did not mean to do that. And angle C. And I just wanted to make this a little smaller. Sorry, I wrote too big. I made a mess on my board. I need to make it smaller. Okay. So now I'm going to use the law of sines to find angle B. That's the one up at the top. So if I'm using the law of sines, I'm going to use sine b over b equals, I know the a's, so I'm going to use sine a over a. So it'll be sine of b over 8.3. And that's going to equal to the sine of 82.9 over 9.1. So to solve that equation, I multiply both sides by 8.3. And I get that the sine of b is equal to, and I crunch that in my calculator, 8.3 sine 82.9 divided by 9.1, and that is 0.9051. When we take the inverse sine, our calculator calculates that angle to be 64.8 degrees. So we add that to our diagram. And finally, we have one more angle to find, but the angles have to add up to 180. So angle C is just going to be 180, subtract 82.9, subtract 64.8. And we get 32.3 for that last angle. I'll add it to my diagram. And we've found all of the angles in that triangle. I have one last example that I want to go through, a bit of an application here. We've got this map that shows us, we've got a boat, a tour boat, and it starts at the dock here in the corner of the map on C, and it goes on a little tour, goes over to Garden Island, 18.1 miles away, and then at about a 100-degree angle it turns and goes out to the Hidden Island, which is 31.5 miles away, and then it's now returning back to the dock. And we need to figure out how long it's going to take to get back to the dock if it's traveling at 12 miles per hour. So since we know its speed, we need to know that distance A, and once we know that distance A back to the dock, we'll be able to divide by that 12 miles per hour to find the speed. So we're going to use the law of cosines here because there's no partnerships, so we can't use the law of sines. We know angle A, but we don't know side A. We know side B, but not angle B. We know side C, but not angle C. So we have to use the law of cosines. So the law of cosines says A squared, that's the one we're trying to find, is equal to B squared plus C squared minus 2B C cosine A. And if we put in the values that we know, 18 squared, 31.5 squared, cosine 100 degrees, angle A is 100. And this is the case, remember we're finding a side, it's pretty straightforward. These are all just numbers, we can type it in. And cosine 100, and we get A squared is equal to 1513.2. So to solve for A, we take the square root of both sides of our equation, and we get that A is equal to 38.9 miles. So to find out how long it's going to take, we just take that distance and divide by 12. Sorry. And we calculate that in our calculator, and we find that it takes exactly 3.24 hours to make it back to the dock. Okay, so that's it for the examples. I want to talk just for a second, and we've already talked about it a little bit, but I just want to talk for just a second about in which cases you can use which law. Now, if you have a triangle and you know two of the angles, you can always use the law of sines. If you know two angles, it really means that you know all of the angles because you could just subtract to find that third angle. So if you have two angles, regardless of which side you have, you can always use the law of sines because you'll have that partnership. Another case in which you can use the law of sines is if you have two sides in one angle and they're across from each other. Let me draw a picture of what that looks like. If you have like a 40-degree angle and you know this is 5 and this is 8. Again, if you have that partnership, you can use the law of sines. The law of cosines you'll use in cases where you know all of the sides and you need to find some angles. So there's no partnerships here. And the other case would be if you know two of the sides and you know the angle between them. In this case, again, there's no partnerships. You know this angle, but not this side. You know this side up here, but not this angle. You know this side here, but not this angle. So, law of cosines is if you do not have any partners. For law of sines, you always have a partnership that you can use to help you. And that's how you know which one to use. And on your homework, there'll be sections where your job is just to look and see which case you would use. Would you use the law of sines or would you use the law of cosines? And for me, this is not about memorizing angle, angle, side, or any sort of, you know, list of S's and A's. It's about looking at your situation and being able to tell if you have, you know, these partnerships that will help you find unknown things, or if you're over here and you don't have a partner to help, so you have to use the law of cosines. In your notes, there's a summary sheet that has a law of cosines and also has the law of sines and the area formula that we've used on the day before today. So next time we meet, we'll be reviewing, and then your test will be the class period after that. Thank you.